15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the Space Nuts podcast. I am your host, Andrew Dunkley, and with me, as always, astronomer at large, Fred Watson. Hello, Fred.
Hey, Andrew. How's it going?
Oh, pretty good, pretty good. Lots going on, lots to talk about. We're going to focus on the rivers of Mars. They've revealed what Mars used to be like, and it looks like it did have a lot of activity. But river flows have made the news, and we'll talk about that. A rare asteroid spotted by Hubble, and a couple of interesting questions. One about whether or not our solar system might have had a rogue planet in the past that got kicked out because there was a black sheep, and a question about the expansion of the universe and the redshift issue. The suggestion is, if we're getting redshift from the most distant galaxies, doesn't that mean that things are slowing down rather than speeding up? We'll try and figure that one out for you, Jeremy. And also thank you to Sean for his question. But we'll start off today with an announcement about an announcement, Fred.
Yeah, look, you can't say that we're nothing if we're not on the ball here.
Absolutely.
We announce announcements.
We are preempting something that hasn't been announced.
Yeah, so just for the for the benefit all those space nutcases out there who seem to enjoy our show, and we're two of the biggest space nutcases, of course. We've had an announcement of a press conference, a media conference, which will take place next week as we speak. In fact, it's scheduled for the 10th of April European time, which is going to be about results from the Event Horizon Telescope, which you and I have spoken about before. And what we've always said is, when are they going to announce the results?
Yeah.
Well, now we know it's the 10th of April. And you can be sure, all you listeners to Space Nuts, you can be sure that you'll hear the news from us.
Yes, we're looking forward to that. We can't tell you anything right now because they haven't told us. We just wanted to tell you that they're going to tell us so that we can tell you.
And after that, you'll know.
That's how it works.
Yeah.
Okay, well, we'll look forward to that. That's next week. But let's get on to this subject of the rivers of Mars. I actually read a pretty intense article about this a couple of days ago, and I was fascinated. I've got a thing for Mars, but this discovery suggests that the activity of rivers particularly went on for a long time, even after the atmosphere was stripped from the planet, which I find fascinating.
Look, I'm glad you've read an in-depth article about this, because you might be able to help me figure it out as well.
Very doubtful.
Because you can't have no atmosphere and rivers. It don't work that way.
Yeah, and that's the big surprise in this.
Yeah, that's right. There's something that we're clearly missing here. But the story is that and this comes from basically the geomorphological evidence. That's just the shape of the landscape on Mars, mostly from orbiting spacecraft, which have got very sensitive radar scanning devices on that give us very accurate maps of the height of the terrain on Mars. So we know that to actually it's probably to a few centimeters. It was a few meters, but it's probably centimeters now. So the evidence seems to be that's coming from that Mars actually had really significant rivers of water flowing on its surface, and these are bigger rivers than we've got on Earth, at least wider, maybe not bigger in terms of volume of liquid, but certainly wider. And that seemed that the other piece of evidence is that because they are of a significant size, they are now thought to have lasted for a long period. In fact, they're talking about, the research group who are looking at this stuff, who are based, I think, in the University of Chicago, they're talking about them lasting for 1 billion years. So rivers flowing for 1 billion years is a significant length of time. And it's no surprise that Mars had rivers, because we have absolutely overwhelming evidence that Mars went through a period in its history when it was warm and wet, like the Earth is, with probably an average temperature very similar to ours, which is about 15 degrees Celsius when you look at it across the whole globe. But that changed, and it's thought to have changed round about 3.7, 3.6 billion years ago, when Mars was basically 1 billion years old. Now, that change is thought to have been due, we've spoken about this before, that Mars lost its greenhouse blanket because there's no plate tectonics on Mars. And so the fact that there's no magnetic field, there's a lot of bombardment by the solar wind, all of that stuff basically stripped Mars of much of its atmosphere. Of course, it still does have an atmosphere, but it's only 1/100th of what our atmospheric pressure is here on Earth. So but the suggestion from this research group is that, okay, Mars lost much of its atmosphere 3.7 or so billion years ago, but the rivers were still flowing then, and they've not just flowing in one place, but in many, many different locations on the planet's surface. And so this leads to a real puzzle in terms of the Martian climate. How can you lose an atmosphere and at the same time have a liquid water on the surface? Because no atmosphere means low pressure, and what low pressure means is that things boil away.
Yeah.
The boiling point reduces. So there are some details in this that certainly I'm not comprehending at the moment. Maybe you are, because you read the in-depth account.
Yeah, well, I read the article, but the article indicated that the issue was we don't understand why this could have existed. Why for 1 billion years rivers flowed on Mars when there was absolutely nothing to protect them.
Yeah, so somewhere there's a greenhouse effect taking place. You know, we really need to see more details of what these scientists are suggesting. It's very interesting stuff. You know, you don't go out on a limb like that and say, well, we've got a real puzzle that it's hard to explain these lakes and rivers with the details that we have. You don't go out on a limb like that and say, if you don't have really strong evidence to back up what you're saying. So I think this is a story we'll hear more about. Maybe we'll understand it a bit better the next time you and I visit it for Space Nuts.
Yeah, and they're talking like 200 rivers. They're talking, it's not just one or two tributaries here or there.
Lots of rivers.
And of course, the study that's gone into Mars to date has proven that there is water there. It's all under the surface. What's the depth of the water if it was all melted down and covered the planet?
Oh, that's 11 meters, but I think that's just from the southern ice cap alone. That's a figure I need to check, actually, because it's something I read rather a long time ago, and that might have been revised.
But that's still a lot of water.
It's a huge amount of water, yeah.
Incredible. So, I mean, it sounds like not all of it's boiled off. It just froze.
No, that's right. Well, we believe that most of the water on Mars did freeze, and we see it there. It's everywhere you look, there's water. A lot of it's covered up with the Martian dust, that ubiquitous red dust that there is on Mars, but plenty of water frozen.
So it prompts a couple of questions in my mind. When Mars had an atmosphere and obviously had flowing rivers and lakes and liquid water, is there any suggestion that it may well have also had some form of life in the form of vegetation, perhaps, or algae, or something along those lines? I guess I'm wanting you to paint a picture as to what Mars might have been like had it not lost its atmosphere.
Well, I've got a lovely artist's impression of a green Mars, which is beautiful. It's got clouds and lakes and seas and rivers. It's a map of like a space picture, but and an accurate one too, an accurate portrayal of what Mars might have looked like if it had vegetation on it. This is a really difficult question to answer, Andrew, and it goes to the heart of one of the whole issues of astrobiology, which is, well, microbial life might turn out to be common, But moving from that to multi-celled life, and that's what you know when you're talking about vegetation, that's what you mean, multi-celled organisms. That could be a very, very big step. And there's a whole body of astrobiologists who believe that that might be very rare, which, you know, that step to get from a microbe up to something that's got multi-celled structure.
So could it be said that Mars just didn't quite get an opportunity to make that leap because of the stripping of the atmosphere?
Well, that's possible. That's right. What I was going to say was we know it's a rare phenomenon because it only happened once on Earth. We had microbes for 2 billion years before there was that step to get from a microbe to a multi-celled organism, and it only happened once because all life on Earth can trace its ancestry back to something called Luca, the last universal common ancestor, and that's why astrobiologists are getting more and more depressed about the idea of there being anything other than microbes out there. Notwithstanding that, microbes, of course, themselves will be a huge discovery. And so far on Mars, we've not seen any firm evidence of them, although there has been, you know, there's circumstantial evidence, first of all, in the form of these methane outbursts that we find on Mars. We don't know where they come from. It could be microbes burping or something like that. But there's also some evidence from, I think it was the Opportunity rover that found rocks with a signature very, very similar to rocks on Earth, which are known to be fossilized microbial mats. And they're at a place called El Tatio in Chile. This is the whole, you know, this is why Mars is so exciting, because we're finding all these things out about it and trying to piece together the puzzle. And I think you and I would put odds on bets that at some point we'll discover evidence of either past or present microbial life, and that will be a sensational discovery.
Okay, let me fast forward. Now, we've talked about the possibility of terraforming Mars if we ever need to leap from this planet to that and making it livable. If Mars can't hold an atmosphere because of its lack of tectonics, then how would terraforming succeed or be able to be maintained?
It wouldn't, because it's a bonkers idea.
Yeah, fair enough. It is an idea that's being
yeah, a lot of people have talked about it. Look, the technology that you'd need to do that is far beyond anything we have at the moment. And it's a very good question. If you did, you know, if you slam an asteroid into it, an ammonia-rich asteroid would do it, would give you a carbon blanket, you know, a greenhouse blanket around Mars. The temperature might go up a bit, and hopefully that makes it a bit nicer if you can breathe ammonia. But you're right. How do you keep it that way? Mars is too small to sustain plate tectonics, and so you lose your atmosphere. You get exactly the same phenomenon happening all over again.
Okay, there you are. Asked and answered. Thanks, Fred. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, a topic we have discussed many times, and that is asteroids. We've also talked about the Hubble Space Telescope many times. And now we've got a situation where the Hubble, along with NASA, have combined to find a rare active asteroid. What is, you know, define an active asteroid as against a piece of rock and ice?
Passive one. Basically, an active asteroid is one that's falling to bits because it's losing its rocky mantle. So just to distinguish between asteroids and comets, comets are mostly icy objects. So we're used to seeing them leaving trails of dust and plasma as they get near the sun. They're very icy. They've got kind of a dirty component to the ice. It's pretty grubby sort of ice. As they get near the sun, they warm up and they leave behind a trail of dust, which shows up as a dust tail because it's lit up by the sunlight, but also usually a tail of plasma, the ionized gas that is outgassed from the ice itself. Asteroids, on the other hand, are not icy. Generally, they are rocky objects, and we think that many of them are really quite dusty. They're possibly even piles of rubble, really, just, loosely bound piles of rubble held together by their own gravity, but not by very much. But there is an object which has been known before to be self-destructing, as it's being described in the press release. And this is now been observed in a really very elegant way. There's a collaboration of various ground-based telescopes, plus the space facilities, in particular the Hubble Space Telescope, which has given us this fantastic image of what looks like an object streaking through the sky. It's trailed as against the stars. If you take photographs of asteroids, you've got to basically move the camera so it's moving with the asteroid and not with the stars themselves. And that what that does is trails out the stars in the background. So we've got an image that's got short star trails, but this extraordinary little point of light, which is the asteroid itself, with two streaks of debris coming from it, a kind of quite brightly illuminated one, and one that's much longer but much less well defined. And so what is being suggested, that this object, asteroid Gault, its name, Gault, it's got a number 6478 Gault. It's about somewhere in the region of 5 kilometers across. And the two tails of debris that it's leaving behind are basically the result of activity on the asteroid itself. Why is it doing it? And the answer is something I was not really familiar with. I'd heard of it, but I really wasn't familiar with it. But it's called a Yorp torque.
Sorry, a what?
Quite so. That's the correct answer, Andrew. It's a Yorp torque. So torque, of course, the twisting motion. It's actually called a Yorp effect, and what it does is produces a torque that makes an asteroid rotate. What is the Yorp effect? Well, Yorp, Y-O-R-P, is actually an acronym, and in fact, it's known as the Yarkovsky-O'Keefe-Radzievsky-Paddock effect. That's what it is, named after 4 scientists. One actually dating back to the 19th century, Ivan Yarkovsky, who figured out, as did the other names in that rather gobbledygook acronym, Yarkovsky figured out that if an object is warmed by the sun, that leaks thermal or heat radiation into space, and it takes off momentum with it. So basically, you apply a force to the asteroid just by the heating effect, and it turns out that is a twisting force. And so the effect of the Yorp effect on an asteroid is to start it spinning. And if you've got an object like this asteroid Gault, which is probably dusty rather than rocky, it's probably a bit of a rubble pile, as it starts spinning, the Yorp effect makes it spin faster and faster. When it gets to a certain level, and I think it's about once every 2 hours, the turning for an object that size, you get the effect of centrifugal force that basically pulls off dust and dirt from its surface. And where does that go? Well, it forms a tail, a dust tail, partly because it's pushed back by the radiation pressure of the sun itself. But of course, this thing is also streaking through space, so it leaves stuff behind it. So an extraordinary set of astrophysics that comes from 19th century thinking, but we're seeing it happening before our very eyes. Something like 800,000 asteroids in the main asteroid belt are catalogued, Andrew. And the specialists basically estimate that roughly once a year among the asteroids in the asteroid belt, one of these YORP disruptions happens as an asteroid spins too fast for its own good and starts falling to bits. But it's an extraordinary situation.
Yeah, and people shouldn't sort of stay up late waiting to watch it fall apart, because this could take a very long time. This is a slow motion destruction.
Yeah, it's not like a collision where things, clag into one another and that's the end of that. This is a slow process. But the ultimate fate of an asteroid like asteroid Galt is basically to be reduced to dust. It will just end up as an orbiting dust pile, getting more and more dispersed in space.
And will that ultimately happen to all of them, or do they all have different fates?
I think it's probably, it depends on the size and the makeup of the asteroid. Some asteroids are pretty solid. In fact, some, as you know, there's one called 16 Psyche, which is a really psychotic asteroid, and it's made of metal. That is not going to fall to pieces because of the Yorp effect. It's too solid for that. So it just depends on exactly what's going on.
So it may just sort of go around for billions and billions of years until it hits something or gets deflected into something, or who knows?
Or just fade. The metal one, you mean?
Yeah.
The metal one, the metal one will last as long as the planets do, I think. What will wipe it out in the end is the sun turning into a red giant star in about,
of course,
3.5 billion years. I know you've got that in your diary.
I have, yeah. I even got, it took me a long time to find that particular diary at a stationery store, but I did ultimately.
Very good.
Yes, and I had to pay ahead too. All right, well, we'll probably hear more about asteroids down the track, because they are fascinating objects, and we always seem to find something new and unusual. And you're listening to Space Nuts. Andrew Dunkley here, Fred Watson there, of course.
0G, and I feel fine.
Space Nuts.
Okay, Fred, let's head into the mystery world of answering questions. We never know what we're going to get. That's what I like about it. People have incredible minds and come up with some amazing questions. I love this one. This comes from Sean, who writes to us from India. Hi, Andrew and Fred. Greetings from India. I'm a big fan of your podcast, and especially the combination of wit and knowledge coming from both of you. I'm the one with the knowledge, Sean, by the way. I was wondering if there is a possibility. I'm just going to keep talking over you, Fred. I was wondering if there is a possibility that there might have been a planet or two in our solar system's distant past that might have been deviated away from its orbit around the sun and gone rogue. Great question. You and I have talked about rogue planets before, and there's a common belief that there are lots of planets out there that aren't orbiting anything. They've just become lost in space, technically.
That's right. Yes, indeed. And there's every possibility, Sean, that happened in our solar system too. And, possibly very, very early in the solar system's history, we know that for the first, probably the first billion years, actually, maybe a little bit less than that, but given that the solar system is about 4.6 billion years old, certainly for the first 600 million years, it was a wild and woolly place with lots and lots of debris basically charging around the solar system. The planets themselves were formed by things banging into each other and sticking together from a disk of material that was what was formed with the sun. So planets in fact, in the early days, planets probably came and went quite a lot. They'd creak together and then run into something else and smash apart. So what we see now is a really very settled version of the way things were. But it seems likely that quite early in the history of the solar system, when the planets as we now know them were formed, there were still objects which were in quite delinquent orbits, if I can put it that way. They were, maybe not as stable as the orbits of the 8 planets now. And in particular, orbits might well have been modified by the extraordinary gravitational force of the planet Jupiter. When it grew to be the giant of the solar system, it certainly would have had an effect on the orbits of other objects within. So that is, the basic picture you've got at a time when the solar system is looking more or less like it is now, but still has a bit of a way to go. And it may well have been that at that time there was one, or as Sean suggests, maybe a couple of planets within the solar system that had orbits that were disturbed by Jupiter. Now, what happened to them, we don't know. One possibility, and there is a smoking gun here, of course, and that's the tilt of the planet Uranus. It's tilted right over on its side. That can only have happened because of an impact with something pretty big, probably something the size of the Earth. And so one of the possibilities of a planet that's got lost is that it was the object that knocked Uranus over, and in that collision was ejected from the solar system. That's a distinct possibility, and we expect to find what you might call orphan planets in the solar system, and maybe the sun has got one or two of those that are lost to the sun, are now somewhere on their own in interstellar space. We do know that there are objects out there, exactly as you've said, which have no parent star to have them orbiting around. It is possible that there are planets that would have formed in that situation from clouds of gas and dust, where places where what we call star nurseries. There are stars and planets forming from these clouds of gas and dust. It's possible that at the low mass end of that, individual planets formed with nothing to go around. But it's likely that the orphan planets that we observe, at least some of them have come from solar systems, and maybe one of them's come from ours somewhere. So yes, the possibility is there.
It does throw into question something we've discussed before, and that is Planet 9. Could it be the rogue planet that we're talking about?
It's possible. Planet 9, a hypothetical world, maybe 4 or 5 times the mass of the Earth. Why do we think it's there? Because there are curious alignments in the orbits of some of the objects in the Kuiper belt, this distant asteroid belt, not the one between the orbits of Mars and Jupiter, but one beyond the orbit of Neptune. There's a belt of icy asteroids, which we call the Kuiper belt. That has objects within it which are definitely aligned in their orbits. And the suggestion is that there is a big planet way, way out in the depths of the solar system, which is doing that alignment, which is shepherding them together. And it's very likely that object would have an orbit that's highly elliptical itself. In other words, it's very elongated. And so that could be an object that was, dealt a blow or some sort of gravitational disturbance early in the history of the solar system, but wasn't thrown out of the solar system itself. It was just pushed into a very long orbit. Yes, so the two could be connected. The only way we'll really tie that down is if we actually find Planet 9, which so far has not happened.
No, they're definitely looking for it, but no joy so far. But as you say, the evidence is strongly suggesting it's there. We just can't spot it. It's not easy to find.
No, it's not, because where we think it is right in front of the Milky Way, which is not a good place to be if you're trying to find a very slowly moving object among the stars.
Yes, well, I think we'll nail it down sooner or later. But
I think so too, yeah.
And thanks for your question, Sean. Hopefully we answered it, but yeah, you were right on the money. We'll move on to a question now from India to the United States, and hello to Jeremy in San Francisco. He says, "Hi, Andrew and Fred. I've been a fan for the last couple of years. I listened to nearly all of your episodes, nearly all of them, Fred. So he's listened to 3. Enlightening, and you do a great show. I've been carrying this question around for years. Never had someone to ask who knows enough in the field to answer. Why are you asking, Fred? I've also searched online and checked some videos on the subject, but still don't find the answer. I'd love to know. So the universe is expanding, and by redshift, we see the expansion is accelerating. And you've discussed on your show that we know this because we see greater redshift in galaxies that are further away, and we know which are further away because of standard candles. But those furthest away galaxies are the ones whose light is sent to us longest ago. How is this incorporated? In other words, why can't we also say the greatest redshift from the light emitted longest ago, therefore expansion was faster longer ago than it is recently, and therefore expansion is slowing?
Yeah, it's a great question, Jeremy, and I think I get what you're asking. And I think the way to answer this is to forget all about the acceleration, because that's a relatively recent discovery. It was discovered, 20 years ago last year. It was discovered in 1998 by, Brian Schmidt here in Australia and a group over in the United States simultaneously. So, but before that, the most the bedrock of our understanding was simply the expansion of the universe itself, and that was discovered in 1929. So for 70 years, all we really knew was that the universe was expanding, that comes from exactly the observation, Jeremy, that you've mentioned. It's that the further away you look, the greater the redshift of an object. And by that, we mean the greater is its recession away from us. The redshift of an object it's the way its light is moved to the red end of the spectrum because of the fact that the universe itself is expanding. So Hubble's law states that, and I think it's now called the Hubble-Lemaitre law, because Georges Lemaitre was a Belgian priest who was also instrumental in this research at the time, back in the 1920s. Anyway, just for now, let's call it the Hubble law. The Hubble law says that the further away an object is, the faster is its recession. And that's just a straightforward observation, but it turns out that if you have a universe that is uniformly expanding, so it's expanding everywhere at the same rate, from your vantage point on one of the objects that's sort of taking part of the expansion, everywhere you look, you see things that seem to be moving away from you faster the further away that they are. So that observation that the higher the redshift, the greater the distance, in other words, the higher the recession velocity, the greater the distance, that's the basic principle of a uniform expansion. It tells you nothing about whether that expansion has changed. And in fact, the Hubble law in its most basic form says that the expansion has been the same since the beginning. It's actually only in the last few years that we've been able to refine that by looking, as Jeremy mentions, at standard candles or standard light sources, which are the supernova explosions. And it was those that essentially give you a different way of measuring the distance, which you can use to check the Hubble relationship itself. And what you find is that the Hubble relationship is still there, that the further away something is, the greater its redshift is. But there's a very slight change in it, which tells you that at about half the edge of the universe, the expansion started to accelerate, that these things are further away than you would expect them to be.
There you are. Answered.
I hope so. Well, I hope you get that, Jeremy, because it's a subtle, effect. But the bottom line is, it's just the basic expansion that gives you the redshift determination.
Yeah. So the speed is not absolutely relevant in the redshift effect, but there's a slight variation that also proves that the acceleration is continuing.
Yes, it's the acceleration that is the really subtle observation. That's why it took us till 1998 to discover it. It's been confirmed many times since then, by the way. So it's well known.
So in other words, Jeremy, both are happening.
Yeah, that's right.
I think is the short answer. And thanks for your question. We appreciate it. Hope we covered it. Hope we sort of hit the right nail on the head for you. And thanks to everyone who's sent us questions. We've got some fresh ones in the other day. We'll get to those. We just thought we'd better get into the backlog because a couple of people sent us questions a little while back, so we thought we'd better get onto those. There's a few we're going to have to review because they're sort of asking questions that are a little bit out there. So we might have to think harder about those. But thank you, everybody, for listening. Thank you, Fred, as always.
It's a pleasure, Andrew, and we look forward to being able to share something about the Event Horizon Telescope very soon.
Indeed, unless they cancel the press conference.
Yeah.
Which, or, that happens. That happens. All right. We'll catch you soon, Fred. Thank you.
See you later, Andrew.
Fred Watson, astronomer at large, and from me, Andrew Dunkley, thanks again for listening. We'll catch you next time on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.